Morning students, this is the continuation of the second method. Evaluate double integral r xy dx dy where r is the region bounded by the x-axis, ordinates x equals to 2a and x square equals to 4ay. This is very important problem. So read the question carefully. R is the region bounded by the x-axis. Bounded by the x-axis, ordinates x equals to 2a and x square equals to 4ay. So we know that x square equals to 4ay is a parabola and it should be like this. This is x square equals to 4ay. And suppose if we take on the x-axis points 0, a units 0a, 2a, 3a like this. X equals to 2a is a line. So it is like this. X equals to 2a. At 2a point x equals to 2a is a line. X equals to 2a. This region bounded by the x-axis. This is x-axis bounded by the x-axis. So this is the region. With respect to this region, we have to find the integral of double integral of xy dx dy. Now we have to find the limits. So x limits. First x limits bounded by the x-axis. So x limits. Through the x limits, what are this region starts at x equals to 0 and x equals to 2a. So therefore limits are x equals to 0 to x equals to 2a. Okay, and region bounded by the x-axis. Bounded by the x-axis means y equals to 0. This is y equals to 0 and this is y equals to 0 and this curve is x square equals to 4ay. From this we can find y equals to x square by 4a. I repeat once again, y limits are y equals to 0 to y equals to x square by 4a. I repeat once again how to find the limits. Double integral r xy dx dy where r is the region bounded by the x-axis. This is very important. Bounded by the region bounded by the x-axis and ordinates x equals to 2a and x square equals to 4ay. We know that x square equals to 4ay parabola is like this. X square equals to 4ay. On x-axis, if we take the units 0, a, 2a, 3a and so on, x equals to 2a is a line equation line. It should be like this. So x equals to 2a touch that intersects at some point, this one. Okay, so this is the region. This region bounded by the x-axis. Bounded by the x-axis. So with respect to this region, we have to find the integration. Now from this region, we have to find the limits. Now when we are finding the x limits through the x-axis, this region intersects at x equals to 0 at x equals to 2a. This region at x equals to 0 and x equals to 2a. So therefore x limits are x equals to 0 and x equals to 2a. Now when finding the y limits through the y-axis, it is what is this? Y equals to 0. This is line when y equals to 0. I told you before that this is y equals to 0, this is x equals to 0. Y equals to 0 means x-axis, that is y equals to 0. Given that the region bounded by the x-axis means y equals to 0. This is y equals to 0. Now this is curve x square equals to 4ay. From this y value y equals to x square by 4a. Now this region through y-axis we are getting y equals to 0 and y equals to x square by 4a. Therefore y equals to 0 to y equals to x square by 4a are the y limits. Now we find the integration. Given that double integral r xy into dx dy equals to, first we have to write the constant limits where constant limits are x equals to 0 to x equals to 2a and y limits are y equals to 0 to x square by 4a xy into dx dy. Now first you have to integrate with respect to y since y limits are variable limits. So x equals to 0 to 2a, x is take outside, and integral y equals to 0 to x square by 4a y into dy into dx. Now this is integral x equals to 0 to 2a. Integral y means y square by 2. Limits y equals to 0 to x square by 4a into dx. This equals to integral x equals to 0 to 2a x by 2 into, substitute upper limit, x square by 4a whole square, that means x power 4 by 16a square minus 0 into dx. This equals to integral x equals to 0 to 2a x power 5 by 32a square into dx. So this equals to 1 by 32a square into integral of integral x equals to 0 to 2a x power 5 into dx. This equals to 1 by 32a square into x power 6 by 6. Limits x equals to 0 to 2a. 1 by 32a square into 1 by 6 into, substitute upper limit minus lower limit, 2a whole to the power of 6 minus 0. This equals to 1 by 32a square into 1 by 6 into 2 to the power of 6 means 64. 64a to the power of 6. So if you cancel 32 2s are, so 2a power 6 by 6. This equals to, and a 6 into a square. So 2 a cube by 6. This equals to a cube by 3. Answer is a cube by 3. Now like this we have to find the integral, but here this is very important, bounded by on x-axis or bounded by the first quadrant. So in problem sometimes they give like this, so you have to read the problem carefully. The region bounded by something, if they mentioned or not, that is very important. So next problem is fifth problem. Evaluate double integral r y dx dy where r is the region bounded by y-axis, the curve y equals to x square, line x plus y equals to 2. In the first quadrant, the region bounded by y-axis. If you observe this problem and fourth problem, that in the fourth problem the region bounded by the x-axis, here the region bounded by the y-axis, the curve y equals to x square and the line x plus y equals to 2 in the first quadrant. In the previous problem, x equals to 2a line equation we can draw easy, and y x square equals to 4a parabola, we know that, but here we don't know, we are not sure the general diagrams. So we have to take the curves given that y equals to, given curves are y equals to x square and the line x plus y equals to 2. From this y equals to x square. From the second curve take y value, y equals to 2 minus x. Left sides are equal, then take right sides are equal. X square equals to 2 minus x. X square minus 2 plus x equals to 0. X square plus x minus 2 equals to 0. From this find the x values. Plus 2x minus 2 equals to 0. X plus 2, if you take minus, x plus 2 equals to 0. So therefore x plus 2 and x minus 1 equals to 0. Therefore x value equals to minus 2 and x equals to 1. X values are x equals to minus 2 to x equals to 1. Here itself we doesn't consider x equals to minus 2 and x equals to 1 because the region bounded by the y-axis. After draw the diagram only we have to know that what are the x limits and what are the